Like any ship, we need our navigational equipment to travel around the world. The equipment that was used during the last world trip 30 years ago is mostly outdated, broken and removed from the ship. That gives us a nice opportunity to start with a clean slate, invest in modern equipment and make a practical and comfortable ocean cruiser. My name is Gijs and this is my dad. And this is Schoener Tijgerhaai. We have recently started a major rebuild to get her ready for new adventures. And we're sharing the process with you. Subscribe to stay tuned. We are not yet completely finished with the installation of the wheelhouse. But before we continue with that, we would like the ship to be mobile again. Since we started removing everything from the old wheelhouse 1 year ago, the ship is officially not allowed to sail. Technically it's possible because the motor and rudder controls are still there, but since AIS and VHF were removed, the ship is officially not allowed to move independently without tugboat assistance. We are now at the point where we can start on the navigational console and install all the essential navigational equipment. And since we're at it, we are going to install all the new navigational equipment in one go. Since the surface of the console is curved, it's hard to take its dimensions. So we'll do a little hardboard assisted design to make a mold of the console dash. For the console panel and other horizontal surfaces, like the table and the pantry, we are reusing mahogany plywood from old but high quality shipping boxes, which is already water resistant and has a good paint coating on the back and varnish on the front. We can cut out the shapes of the equipment while the panel is flat and check if some modifications have to be made when the panel is installed. The next important thing is getting some power supply to the console. Most equipment uses 24 volts direct current, because that's what's coming out of the batteries. There's a main switch for the 24 volts located in the engine room, but since most 24 volts consumers are fused underneath the console, I'm installing a secondary switch so I can isolate this switchboard and work on it safely. For the switch I can reuse the 24 volt switch from the old wheelhouse, which is way bulkier than necessary, but we have the space. We are also reusing old automatic circuit breakers, because they're still working and there's nothing wrong with them. They're bigger than modern ones, but that makes it easier for my thick fingers to get the right wires in the right holes. On older installations, it's common that all these breakers are connected with a bare copper strip. Nowadays, that's considered a bit dangerous. And since we have some modern insulated forked bus bars left over that coincidentally exactly fit the old circuit breakers, we can create a safe switchboard using old parts. I'm installing more circuit breakers than we have use for at the moment, but future us will probably be thankful for that. These days it's very common to use terminal blocks in electric cabinets and switchboards. Every terminal would have a number that corresponds to a number on the electric drawing, making it easy to find which wire does what, because it is impossible to follow the individual cables in these cabinets. I personally prefer to use a 2-core cable, running straight from the breaker to the consumer, with no terminal blocks in between. Because it makes the system simpler and less connections make for less possible errors. It does take up much more space, so for the navigational lights I have to make an exception. Because the switches for the lights are on the front panel of the console and they only switch the positive line of the 24 volts. Instead of running a bunch of big 2-core cables through the whole console, I will install a terminal block close to where the cables exit the console and connect the negative wires straight from the breakers to the terminal block. The positive wires are also connected to the terminal block, but via the light switches. Installing new navigational equipment is very easy, thanks to a system called NMEA 2000, which is a communication standard that almost every manufacturer of navigational equipment uses. It consists of one backbone wire to which all equipment can be connected using T connections. There is some navigational hardware that needs to be installed out of sight underneath the console. That being the network switch, which allows the radar to be controlled from both the poop deck display and the wheelhouse display. Then we have the autopilot computer, which does what its name says it does. And then we have the ship module. This little device enables equipment that still uses the old communication standard NMEA 183 to connect with the newer communication standard NMEA 2000. In our case, that is especially of interest for the older Automatic Identification System, or AIS, giving us the possibility to view the name of the ships around us on the digital chart display. There are some power consumers on board that only work on 12 volts, like the Echo Sounder and the VHF marine radios. For them, I'm installing a third row of circuit breakers, which is supplied by the DC-DC converter, converting the 24 volts to 12 volts. The lower half of the wheelhouse will be paneled with walnut plywood, which we bought new because it has a nice brown color when varnished. The mahogany has a light orangey color, where the walnut is more dark brown. We don't want these colors of wood to clash, so we're applying 2 layers of walnut colored wood stain on the mahogany panels. It would be very hard to match the colors of the 2 different types of wood, but we're happy if they complement each other in the interior. I plan to give the console a final high gloss finish, but the satin finish of the wood stain is starting to grow on me. Plus it gives a lot less reflection of sunlight. I don't know. Let me know what you think in the comments. Next is the installation of the equipment. Our chart plotter is a 19-inch touchscreen display, because Dad is not that good with small displays and he should be able to work with it just as well as anyone. Then we have an SD card reader for the digital charts, controls for display and autopilot, we will also install a separate display for the depth indicator or echo sounder. We have 2 echo sounders, one of which is connected to the big display and the other one is a standalone unit with its own display. Then we have the VHF marine radio, the AIS or Automatic Identification System, and some small buttons like the rudder control tiller, a horn button, and buttons to start and stop the diesel generator, which powers the future bow thruster. We will also install a bow thruster control tiller when it has arrived. And finally, a regular Bluetooth radio so we can listen to our favorite music. We still have a lot of antennas, sensors and navigational lights to install on the roof and in the mast, but we are waiting for a little bit better weather before we start on that. A lot of cable pulling and connecting further, this is the result. That was by far the single biggest investment of the entire rebuild. But we knew it would be and we were prepared to make a dent in our savings. For now, we will remove most of the equipment again until we actually go sailing, for obvious reasons. The console still looks very unfinished, but when all the interior paneling is in place, we will finish it off with dark hardwood slats. And at the wheel on the poop deck, we will install a 9-inch display as well as a VHF and autopilot controls, but that's for another time. And this is all for now. Thank you for watching and I'll see you next time.